So this section is 7.2, completing the square. What we're going to do here is we are going to use the properties of values that are squared and have this help us solve equations. So we're going to try to factor down our quadratic so that it factors down into a perfect square. And then we'll take the square root of both sides, and we should be able to solve for our x. So if we know x plus b over 2 squared is equal to k, then we could take the square root of both sides, and we would be left with x plus b over 2 is equal to plus or minus k. So here's why this works in a simpler form. If I told you that we had an equation of x squared is equal to 25, we have a few ways we could solve this. One of the ways that we would solve it is we would go to take the square root of both sides. When we take the square root of both sides, the square root of a square is gone, so we just have x equals and then plus or minus 5. Because the square root of 25 could either be a positive 5 or a negative 5. So that's essentially the process that we're going to use to solve these equations. We're going to factor down our quadratic, and for these first two examples, they will factor into perfect squares. And then we will get something that's squared on the left-hand side, and then take the square root of both sides of the equation. So, problem 1. X squared plus 10x plus 25 is equal to 49. So we need to factor x squared plus 10x plus 25. We know that our first two terms both have to be x. And we also know that our last terms are going to be the same because I told you that these factor to be perfect squares. But even still, the only option here that would work would be plus 5 and plus 5. That would give us our outside-inside value to give us our 10x, and our last to still give us 25. Now, instead of writing this as x plus 5 times x plus 5, we're just going to write this as x plus 5 squared is equal to 49. We can do that because we just have two x plus 5s being multiplied by one another. So now we could take the square root of both sides. So the square root of x plus 5 squared is just x plus 5. And the square root of 49 is plus or minus 7. Now to get our x alone, we would need to subtract 5 from both sides. Now when we're subtracting 5, we are subtracting 5 from both the positive 7 and the negative 7. So positive 7 minus 5 is 2. Negative 7 minus 5 is negative 12. So my two solutions here are negative 12 and 2. Let's look at the second example. X squared minus 6x plus 9 is equal to 32. So we are going to factor this left-hand side. So we know, once again, our first terms should be x and x. And then here we know that our last terms should be 3 and 3, not only because I told you that these were perfect squares, but because they're the only ones that make sense, that would multiply to give us the 9 and then add to give us the negative 6. So this will factor to x minus 3 times x minus 3. Or we could just write that as x minus 3 squared. is equal to 32. Now, many of you should jump down to that second step right from the first one. So now we have something squared equaling 32, so we can take the square root of both sides. Doing so, this leaves us with x minus 3 is equal to plus or minus the square root of 32. When we break that down, it ends up being 4 square root of 2. That's what we talked about last unit, our radicals, so you should be good at breaking those down. Then to get the x alone, we would need to add the 3 to both sides. Now, the way how we're going to write this, because 3 and 4 square root of 2 are not like terms, we are just going to write our final solution as 3 plus or minus 4 square root of 2. And that is our final solution. We do have two answers there because we have a plus and a minus in between these. We will never write these as decimal answers. We will always leave these exact and in the square root. We're not always going to be given quadratics that factor perfectly. So we need to find the value of c that will make this quadratic a perfect square. Because sometimes we need to create that perfect square ourselves out of our quadratic. So we need to figure out, if I have x squared plus 12x, what I would need to do to that 12 in order to come up with the value for c that would make this quadratic into a perfect square. So let's take a look at those first two examples again. Take a look at the negative 6 and the 9 and the 10 and the 25 and see if you can come up with a way how they're related to each other in the same way. Well, if you look at the 10, if you take the 10 and divide it by 2, you get 5 and 5. And so that would make your outside and inside give you the 10x. But then from the number 5, you can get to 25 by squaring it. So if you take the value attached to the x, so in this first example it's 10 and we divide it by 2, and then we square it, we should get our value at the end that leaves us a perfect square. Same thing for number 2. 6 divided by 2 is 3, and 3 squared is our 9. So that's going to be our process to find our perfect square. So number 3, x squared plus 12x plus c. So we need to take our 12 and divide it by 2, and then we need to square that value. So 12 divided by 2 is 6, and 6 squared is 36. So here our value for c is 36. Number 4, x squared plus 10x plus c. So we need to take our 10 and divide it by 2. And then we get 5, and then we square it to get 25. So in general, this is the general format of how we write a quadratic is x squared plus bx plus c. And so here, our c value we can find by dividing our b by 2 and then squaring it. So that means that when this is a perfect square, it would factor to x plus b over 2 squared. That's where that b over 2 came from on our first slide. And once again, this would only work if our c is equal to b over 2 squared. Alright, so now we're going to do some actual examples where we need to use completing the square to solve our quadratic equation. So problem 5, x squared plus 8x minus 20 is equal to 0. First off, you would notice that the quadratic is definitely not a perfect square to start off with. So we want to create x squared plus 8x into a quadratic that is a perfect square. In order to do that, the x squared and the 8x need to be alone on the left-hand side of the equation. So that means I have to add the 20 over. And I'm going to leave a space after my 8x so that I can complete the square. So now I want to make this quadratic into a perfect square. So to do that, I need to take my 8, divide it by 2, and square it to get 16. Now if I add 16 to the left-hand side of this equation, to keep the equation the same, I need to add 16 to the right-hand side as well. Well, x squared plus 8x plus 16, this factors to x plus 4 times x plus 4. Or just x plus 4 squared. And then this should be equal to 20 plus 16 is 36. Now we'll square root both sides. X plus 4 squared, when we take the square root of that, we just get x plus 4. The square root of 36 gives us plus or minus 6. And then to solve for x, we would need to subtract 4 from both sides. We have to make sure we subtract the 4 from a positive 6 and from the negative 6. So positive 6 minus 4 is 2. And negative 6 minus 4 is negative 10. So my two solutions here are negative 10 and positive 2. Tune in to part 2 for the remaining examples.